Hi, I'll be going over immunosuppressants. So, what are immunosuppressants? Immunosuppressants are medications that are aimed to prevent the immune system from mistakenly attacking healthy cells and tissues. Immunosuppressants, even though they are effective in curbing harmful immune responses, they also carry the consequences of reducing the overall functionality of the immune system, which increases susceptibility to various infections. Mainly, immunosuppressants are employed in the treatments of autoimmune disease, where the immune system fails to differentiate between foreign invaders and the body's own tissues, which then results in the tissue damage as well as inflammation. By administering immunosuppressants, healthcare providers aim to mitigate these determinal immune reactions by alleviating symptoms and potentially inducing remissions in certain autoimmune conditions such as alopecia areata, which is an inflammatory bowel disease like Crohn's disease. In the context of the organ or stem cell transplant, immunosuppressants plays an important role in preventing rejections of the transplanted organ or cells. During allogenic stem cell transplants, where unhealthy stem cells are replaced with donated ones to rebuild the immune system, there then exists a risk of graft versus host disease, wherein a newly transferred immune cells attacks the recipient's tissue and organs. Immunosuppressants are administered to mitigate this risk during and after the transplant process. Also, in similar organ transplantations, these medications are indispensable for preventing rejections of the transplanted organ, as the immune system perceives it as a foreign and mount an attack. You're wondering, what is the pathway of immunosuppressive drugs? Immunosuppressive drugs are important for managing diseases which involve abnormal immune response, such as infections, allergies, autoimmune conditions, as well as transplant rejections. These drugs target signaling pathways such as JK/STAT, NF, mTOR, MAPK, to dampen immune activity. The main drugs, such as tofacitinib and everolimus, have been developed to target these pathways, which shows effective in conditions like organ rejections as well as autoimmune disease. Research continues to explore new agents, with many in clinical trials as well or preclinical studies. The JAK/STAT pathway, for example, regulates cytokine production and immune response. Drugs like tofacitinib and upadacitinib shows promise in treating autoimmune disease such as rheumatoid arthritis. Other pathways such as PI3K/AKT, mTOR, and NF/KB are also being explored for autoimmune suppressive therapy. So, therefore, immunosuppressive drugs have a revolutionized treatment of autoimmune-related disease. There is still an ongoing research promise for a more effective and targeted therapies in the future. So, how does immunosuppressive drug inhibits this pathway? An example of this are corticosteroids, which is like prednisone. They exert their immunosuppressive effects through genomic and non-genomic actions. At low dose, such as 30 milligrams, they bind to glucocorticoid receptors in the cytoplasm, which leads to gene expression, regulation, and inhibition of pro-inflammatory cytokines like the IL-1 and IL-6 at a high dose of less than 30 milligrams. Corticosteroids impacts membrane fluidity and intracellular calcium concentration, which affects signaling pathway like MAPK and inducing regulated apoptosis and thymocytes. Azotorphine interferes with DNA synthesis by inhibiting nucleic acid synthesis, while myofenolic acid (MPA) inhibits inosine monophosphate dehydrogenase by blocking purine synthesis and adhesin molecules. Methotrexate inhibits DNA RNA synthesis by down-regulating the adhesin molecules as well as the IL-beta and IL-IR interactions. Calcioneurons inhibitors like cytoplasmic and tacrolimus block NFAT transcription by inhibiting calcineurons, preventing T cells activation and cytokine synthesis. The CSA binds to cyclophilin, while tacrolimus binds to FKBP12, which inhibits both inhibiting calcineurin. CSA also increases TGF-beta, contributing to immunosuppression but potentially causing nephrotoxicity. CN2s, on the other hand, also have a high risk of nephrotoxicity, which causes acute and chronic damage, including their arterial hyalinosis and interstitial fibrosis. Tacrolimus, superior to CSA in preventing rejection, also increases glucose intolerance, which the extended-release formulations like Maltodose offer once-daily dosing and improved absorption. This reduces the dose and sustaining calcium inhibitions. And these are my resources. I hope my presentation made sense, and sorry if I mispronounced anything.